So these are our speakers who you already met, the panelists who you haven't met, and I'll let them introduce themselves. From your right to left is Ben Pryor from Phoenix Contact, which was the supplier partner of Lucky Peak Power. Tom Henwood from Kyndryl. Darren Kimura, who is the Chief Operating Officer of Zedata, which was Philippe's partner from Schlumberger. And Herman Obermeyer, who is I think, Vice President, but the division manager for Andritz for automation. So I'd like to get all of you involved. So maybe we'll start with Herman, if that's okay. I'd like to know, maybe you could explain to the audience, your view, a little bit about your business, and then what your perception and work on edge computing and industrial edge computing. And you'll have to share mics, folks, okay.
Thank you. Yeah, Hermann Obermeyer, responsible for digitalization in the Andritz Group. Andritz Group itself has roughly 20,700 employees and is a huge manufacturing for machinery and equipment. And we also have roughly 1,800 automation engineers in the group. And since 2007, we are developing software for automation and digitalization. And for the discussion today, I want to give you my input in terms of why did we develop an edge control ourselves. The story behind is very short. We have a lot of automation engineers, and we have just a few data scientists. And it was always the same. We all know that AI is key for future functionality. There's no discussion about. And we always had the problem that we couldn't deliver in one project together the AI functionality and the control system. And for that, we developed the engineering toolchain to combine the programming of the automation part together with the AI part. And this is the reason why I want to hear what is your opinion about that. Is this a problem that also is in the field, or is this just a problem what we had, that there are so many functionalities in the AI engine which cannot be used because of the lack of the engineers which can deliver this?
Okay, thank you, Herman. I'll move to Darren now, if that's okay. Darren, would you introduce yourself? And I think we may have had a little explanation of your product, but I think we'd like to hear a little more about your company and what your mission is.
Sure, sounds good. So hi everyone, I'm Darren Kimura with Zedata. First question I always get asked is, what does Zedata mean? So I'll tell you right now, it's Moroccan for innovation and new. And that's really what we're trying to do at Zedata. We're a software provider. We have two primary technologies that we focus on. The first is an open source operating system which sits on edge devices in the factory floor, in the process automation systems, in the windmills, in the solar farms, wherever you need compute, that's where our operating system can live. And again, it's in the open source. The second technology we have is a cloud-based orchestrator, which is used to basically control, manage, monitor each of those nodes, we call them nodes, the edge compute systems that are out in the field. And also we have a marketplace which extends the power and capability of the applications that may be running in, for example, AWS or Azure. We allow you to bring that all the way down to the local compute so you can do exactly what you would do otherwise in the cloud, but on the local server in the factory floor.
Okay, thank you. And Tom, maybe you could, people are probably not as familiar with Kyndryl in this space, so if you could explain a little bit about Kyndryl and maybe why Kyndryl is relevant to a program on edge computing.
Yeah, thanks, Harry. I appreciate it. So hi, I'm Tom Henwood. I am a client technical leader out at Kyndryl. So a lot of you probably are not familiar with the name Kyndryl, and don't be ashamed. We've been around for decades. However, we used to be called IBM Global Technology Services, and we spun off last November. So we're a 90,000 employee infrastructure managed services company. We handle everything from private wireless network connecting IoT devices and large outdoor areas, whether it's a well field, whether it's a steel mill, manufacturing facilities, those types of things where it's hard to connect workers, it's hard to connect assets in harsh or very large environments. We do that work. We also do edge computing, IT, OT integration work, as well as cloud modernization, security, desktop services, kind of the gamut of the application stack.
Okay, thank you. And Ben, I'll give you a shot too. If you had to explain Phoenix Contact and your role in a nutshell, would you do that, please?
Oh, yeah. Well, so Phoenix Contact, I think many of you know who we are. A lot of times people, they hear our name and the first thing that comes, little green terminal blocks in the back of all the devices or terminal blocks. We're a 100-year-old company here coming up. But we do much more than that. Like my role specifically within Phoenix Contact is within the vertical market space, specifically electric power, T&D. So we find a lot of our products can fit the gap where, we're not the sensor, we're not maybe the SCADA and all that, but we can be the devices that will interconnect all those systems. And I mean, it could be from down to the wire, all the way out to the network switch, out to remote IO. So we find our systems being more and more used to allow you to interact or get the data from those end devices that are being increasingly deployed. And especially in the utility space, in our world, it's a little bit more interesting because we're dealing with a regulated environment versus going to a factory floor or a private enterprise where you don't have the same rules and requirements. So how do you take those technologies and deploy them in a very reliable and resilient manner so that you're not affecting your customer's process? And so that's really where our team tends to work in that area.
Okay, thank you. I'd have to say Derek's presentation brought me back a little bit to remember, and you showed that enunciator panel, and it brought me back to a plant that I used to work in that had something like 1,200 enunciator windows, and very many of them said, "This equipment, trouble." And that was the way, and so the methodology was send the operator. So I think having more windows isn't necessarily going to solve the problem, but no matter how many you get, you do tend to find them aggregated and kind of dead-ended like that. So it's a real situation, really, regardless of the size or the scope of the plant. This plant I was working in was a billion-dollar plant, but still had that kind of issue.
Yeah, we just did the enunciator on just one unit, and when I showed you the alarm templates, I ended up making probably over 80 of them just for that unit, just to show basically just the systems and all the devices under it. But just for that one unit, there's like probably 360 end devices or alarm points for that unit. So when you think about that in the big picture, when you have an operator trying to look through 360 alarm points, it's like, yeah, that's a problem.
Yeah, it is. Okay, I'm happy to open it up to questions from the floor now. I have a couple of my own in mind, but if someone has a question they'd like to ask, just please raise your hand and we'll bring a mic to you. If not, I'm going to just keep going because I wanted to ask Philippe about, you mentioned you had 3 classes of applications there. I should have the slide in front of me now, but you had marketplace applications, and could you explain a little bit more about what that means? Because I didn't catch that.
The marketplace is basically we have Michelin. So I work for the technology center, right? SLIC, and we have this unit called Agora, which is our business. They work with the clients to get the requirements and then build the solutions that are going to solve their problems. And also with partners to develop custom solutions. And what happens is the marketplace is basically this selection of different applications for solving specific problems, right? So that it's like a catalog of solutions that you could use and deploy to our gateways.
Okay, so is that a Schlumberger?
Agora is Schlumberger. Yes.
Okay.
Yeah.
So it's a family of applications you can run there for different parts of Schlumberger.
Yeah, and we have partners as well that they have that work with us that develop solutions to put in our system as well.
Okay. Other questions? I'm going to open it up. I don't want to dominate here. Don't see any. Okay. Was there one? Oh, go ahead, please. Oh, we have a.
Hi.
There we go.
Okay. Question to Felipe. I thank you very much for a presentation. Thank you very much for all presentation, right? Very, very good. But my question for Felipe, it's about, I saw that you use it like in the visual analytics, right? Some kind of maybe object detection use case, right? That you recognize some of the security equipment or recognize some of the digits of some analog gauge, right? My question is about it's how if it's machine learning model that you use there, how much accuracy you got from your cases, right? And the other question is about if you, for example, in your an analog gauge, you have an error, right? So, like, for example, you say it's showing 9, but you say for any reason your model say 7, right?
Yeah.
What kind of solution you do for something like this?
No, that's a good question. So it's yeah. So I don't remember exactly what is the number, but it was pretty high, the accuracy. So the good thing is that in that particular case, it's in a controlled environment, so it's not in a place. It's not out in the desert, right? So it's a bit easier to control. And the solution as a fallback for what you're saying is, in addition to a digit, so we read the gauge and then digitize, right, transforms it in a number and push that up. It also takes the snapshot and then transfer that to the remote server as well. So if there is something that it is not well calibrated, someone noticed, oh, there's some issue here, you still can go and match to see what was the particular error. Right.
Okay, another question? Not seeing one, I'm going to ask another. Excuse me, I can't stop myself. But Herman, you mentioned AI being an important component in automation, and I'd kind of like to ask the supplier panelists to maybe address that a little bit more depth from your perspective. I'd like to know kind of what industries and applications you think are that you are seeing more in your business, and maybe are there specific applications, industries that you think are starting to grow within your own business?
Over the last years, we have learned what the capability of artificial intelligence is. Most of the architectures collect data on shop floor in the processes and make the calculations in cloud infrastructure and the way back. And we have learned that there are also processes which need real-time efficiency and real-time feedback. And so this was the idea to develop a hybrid concept where the real-time AI functionalities can be deployed on-site within the control system, and all others can be connected to a cloud architecture where enterprise calculations are going on, or factory calculations, but on a machinery, on a process island. Sometimes we have seen that there is a real-time reaction, very important, and there's not even one machinery what we deliver which doesn't have soft sensors. Soft sensor is really a very efficient method to improve the stability of the machinery, of the equipment, because you can substitute sensors in case of, and this is a method which makes no sense to transfer data in the cloud and calculate and bring it back, because this is too cost efficient. And this was, at the end of the day, this was the start of our own development to rethink how can we reduce the complexity of the applications, of the AI applications, that typical automation engineers can use this functionality. And this was our answer to that we can now ship with every single machinery really very easy AI functionality within every system.
So machine control and analytics and skid-mounted systems,
Yeah.
we call them in the US, skid-mounted systems. That's your answer?
As I said in the beginning, the situation we have been faced that we have less data scientists which have the capabilities or had the capabilities. And now with this move, we have the chance to deliver each and every machinery with these AI functionalities. And we have implemented the complete scope of machine learning notebook functionalities. These guys which are able to program in Python, they program in Python. And the automation guys love function blocks. And this is the approach what we did. We offer all our automation engineers a full set of functions that they can configure.
Okay, I will now turn to Darren. You have, I'm in your view of projects or your universe of projects, how important is AI and where are you seeing it? And there's certainly many projects that I think you've executed where it's not relevant. So could you give us a perspective on that?
Yeah, I would say that just about, because we're in the infrastructure, we are used broadly across pretty much every single vertical you can think of that edge computing is operating in. And in our marketplace, our end users put the applications that they may develop proprietary or might be open. But I will say in almost absolutely every single vertical, AI is being used. So it's become the thing you have to have, I think, now as you're thinking about digital transformation or modernization. One example here at the show is one of our customers in the hallway is PeopleFlow. And they're using AI with the edge computing to be able to create a more efficient pumping system, which is able to measure against head and make calculations on a variable basis to adjust for pump motor, pump load, and things of that nature, but do that across the thousands of different pumps that might be, for example, in a refinery. And that's just one example. We see in the retail case a lot of video use cases, like Felipe mentioned, where in the past it was simply, still shots trying to identify things like license plate numbers, now going as far as trying to identify make and model and color even of vehicles that might be in a parking lot. So it's everywhere.
Okay. Tom?
Yeah, I'll add on to that. I think visual AI as well is really impacting manufacturing as far as defect detection. You may have visual AI running on a production line to identify if there's a defect in a product, if you're screwing a cap onto a particular bottle, has it been screwed on all the way? What's your level of confidence that it's been screwed on? And as these are going by very quickly, it can check product numbers. It can check if certain things have been seated correctly on a unit and alert when it's not, so that you can intervene. And when you use these types of technologies, you can really see an increase in the production flow that you can get through, a reduction in the number of defects and the false positives on defects that maybe someone would have stopped a production line for, would have taken a unit off the line that was not really defective, but falsely alerted. So the newer, machine learning models that you can put together in the AI is really certainly allowing for some real improvements in manufacturing. And also, I would say using vision AI for safety. Is someone in an area that's hazardous? It can alert on those types of things as well, and you can really use it for health and safety of your workers.
Okay, Ben, do you have any comments on that? I would think you might be able to say, no, we don't use it at all, but I just wonder what you're going to say.
I was going to say, I'd say, the days of we used to joke that the utilities were a hub and spoke, right? Central generation, hey, you got 6 walls you're dealing with. Those days are far less, and it's more distributed. You said some of the talks where people are talking about distributed automation, distributed generation. There's a lot of sensors out there. You have to be able to detect faults in the lines, not at your plant anymore. Everything is being further and further spread out. So there's a lot of work being done right now. People are gathering all kinds of data. Can you do predictive, can you predict when a fault's going to happen based on certain scenarios you're seeing online? Can you, there's certain things you're not going to do. We always make the joke. Someone's like, oh, we can predict everything except the squirrel in the neighborhood 2 doors down from me who tends to climb into a transformer every other week. So no, I definitely see the utility space. You got to remember, these guys are covering more area. They're not getting more people. So they actually have to work. We say, work smarter, not harder. That comment is very true. So how can they, make their systems more efficient? How can they increase the line flow? Can you do dynamic line rating using all this data? Well, you got to have the algorithms that can make the adjustments in real time. In the sense of California, it's already been talked about using, I know you guys are talking about vision systems, but the fires they had out there with wildfires, you can't just keep shutting power lines down every time you have high winds. How can you use systems that actually can monitor a line's movement using accelerometers? And maybe before that line hits the ground, using a lot of remote communication, 5G, talk about all these new systems we're deploying. How can you shut that line down with a protective relay before it hits the ground? All this requires an immense amount of data because you can't afford to be, oh, my bad, we just took that segment down and it was, not what we saw. So you have to be all the data has to be present and it has to give you the right information for you to make those type of decisions in that short period of time.
Okay, thank you. Give one more opportunity for the audience if there's a question remaining there. Not seeing one. I just want to thank these presenters and panelists for a great presentations and great comments on the session. So thank you all very much.